Hello, Honors Chemistry, and welcome to your Chapter 9 review covering clearly Chapter 9. All right, so first let's just highlight some of the things you're supposed to know. One, you should definitely know about the electromagnetic spectrum. You should understand what a photon is. You should understand what a continuous spectrum is. You should be able to talk about the relative wavelengths, energies, and frequencies of different types of radiation, and you should be able to rank them accordingly, okay? So make sure you know all of that. In addition, you should be able to mathematically relate those quantities, right, by our equations, which say C equals lambda nu, E equals h nu, and E equals hc over wavelength, right? And you should know that C stands for the speed of light, which is 3.0 times 10 to the 8th meters per second. You should know that h is 6.626 times 10 to the negative 34th joules times seconds. You should know that defining our other variables, right, this stands for, right, wavelength, commonly measured in meters. Well, meters is what you need to use in the equations, right? This is our, nope, that's not it, frequency, measured in units of 1 over second, also known as, right, hertz. We also have energy, measured in units of joules, right? And again, this is known as joules per photon, right? And so all of these are the energy, wavelength, and frequency of a singular photon. And if we want, we can scale it up to talk about an entire mole of these photons, okay? And note that you should be able to look at these equations and come up with a relationship, right? Like C is a constant, so if this goes up, this must, right, go down, right? Here, if we were to rearrange this, right, so that it says E over this is equal to that, right? This is a constant, right? So if this goes up, then this must, right, go up, right? And that tells us the type of relationship that those variables have. All right, next up. Let's look at some problems. We're not going to work these, we're just going to set them up because they're easy problems. But what is the wavelength, right? So this is what we're solving for in nanometers of light with energy equal to this, right? So this is my energy. And then we'd now like to know what the color is. So if I have energy, which is E, and I'm looking for this, I'm going to use the equation that relates those things, right? Which is E equals hc over wavelength, right? For those of you that tend to set things up right and then do the math wrong, here, great idea to just go ahead and isolate the variable you're looking for, right? The variable I'm looking for is this. So let's go ahead and get that by itself. In order to do that, I'm going to what? Right, I'm going to multiply both sides by wavelength, right? So then I'm going to have E times wavelength is equal to H times C. And then I'm going to do what? Right, I'm going to divide both sides by E, which means that I'm going to have wavelength is equal to HC over E, right? And then I literally plug everything in, and if I do it right, I should come up with the right answer, okay? Next up, it says, what is the frequency, so now I'm looking for this, associated with radiation of this many micrometers, and what kind of information is that? Right, it's in micrometers, which means this is a measure of wavelength. So what's step one? Right, step one is I'm going to turn this into meters, right? Step two, right, I'm going to plug them into the equation that has to do with that, right? C equals lambda nu, I'm looking for frequency, so I'm going to get frequency by itself, which means I'm going to, right, I'm going to divide both sides by wavelength. So C over wavelength is going to give me my frequency, yes? And then what's the only thing I need to think about again? Right, converting this to micrometers first, right? All right, next up it says, what is the energy, so E, of radiation with a frequency of this, so this is nu. So then I just think, well, E and nu, right, that's tied together by this relationship. And turns out E is already isolated, so I just need to plug in my information. Yes, and this is already in hertz, right, which when we go type that in here, or write this out, we're going to say 6.75 times 10 to the 20th, 1 over seconds, or we could just say over seconds, right? And then that's going to work with our units to make sure we end up with just joules as my final unit. Yes? All right. Next up, other things you should know from Chapter 9 include atomic structure, right? So you should know information about the Bohr model, right? How it's arranged with our central nucleus, and then our orbits, where our electrons are located, right? And you should understand that Bohr and QM, right, what they have in common is, right, we have that central nucleus, and then we have the concept of quantized energies for my electrons, right? We have quantized energies for my electrons, meaning they don't exist everywhere, right? They exist only in distinct, defined places, right, based on the energy transitions. So anyway, Bohr, QM, and in QM we have that hierarchy of shells, subshells, and then orbitals, and then electrons fill those orbitals, right? Go read that summary on haiku as needed, and go look back at your notes as needed, okay? Then atomic structure, knowing what the structure inside of an atom looks like, means that we can write some electron configurations, or also known as the arrangement of electrons within atoms, right? Note that we have our three different ones, right? We have our orbital notation, our standard notation, and our noble gas notation, right? So let's say we wanted to do, let's pick an easy one. Let's say we wanted to do carbon, right? If we wanted to do our orbital notation, right, we'd start by writing out our orbitals, right, and then we would fill them on the way. So carbon has a total of 6 electrons, right? So we would put 2 in here, we would put 2 in here, and we'd do our 2 p's, and then we'd have to put 2 more in there, and we'd apply Hund's rule and put them in 1 orbital each, right? Alternatively, we could just write this version, 2s2, 2p2, or we could write the noble gas notation, which means I'm going to go to the noble gas behind carbon, which is helium, and then write what comes after that, 2s2, 2p2, right? In terms of coming up with these quickly, right, that all boils down to understanding your periodic table, which we talked about in class the other day. So, right, going back to the fact that our group number, specifically group number, the one that is before the A, right, tells us the number of valence electrons, which is convenient, right? So we know that this has 1 valence electron, right? 1, 2, and then 3, 4, 5, 6, 7. And we also know that we have our period numbers, which correspond to our valence shells. Yes? All right. So from here, we can just really quickly write noble gas notation for every single element on the periodic table, right? So let's say we wanted to do sulfur, right? We would start with the one behind it, which is neon, and we'd write what comes after it. So neon, 3 comes after that, right? This is S. We've crossed the S. We're starting the P, 1, 2, 3, 4. Yes? So 3p4. And that would be sulfur. Yes? All right. Let's say we wanted to do something a little bit bigger. Let's say we wanted to do antimony. So we'd go back to the one before it, which is krypton. And then we'd come down here, 5. We are past the S, so S2. And then we are past the D, so 4D, 10, because D is our back one. And then we are 1, 2, 3 into the P's, so 5, P3, okay? Let's say we wanted to do something even bigger. Let's say we wanted to do, I don't know, let's say we wanted to do mercury, right? So mercury means we go to the noble gas before, which is xenon, and then we'd go to the next, so we'd start with 6, and then we are past the S, so S2, and then here, what's this? Right, that's our F's, which are back 2, so this would be 4, back 2 shells, right, so 4F14, and then we come here, right, and that would be 5D10, yes? All right, and then we could do obviously simple ones over here, so let's say if we want to do potassium, right, we'd go back to the one before it, which is argon, 4, S, and we are 1 into the S block. So this is how we write electron configurations, and they should be that quick and easy. So look this over and make sure you can do that. If not, you should see me sooner than later. All right, then that brings us to our periodic trends, right? Where we talked about periodic trends, including atomic size, also known as atomic radius. So atomic radius does what? Right. Decreases. And does what this way? Right, it increases. Oop, that's not what I meant to do. Increases. All right, and why does it increase going down? Right, because we're adding shells, right? Every time we go down one, we're adding a new shell, so my atomic radius increases, right? As we go across a period, my atomic radius decreases because, going back to what we talked about before, right? As my nucleus gets more and more protons, right? And as we add more and more electrons to the same shell, that's the important part, adding electrons to the same shell, this attraction gets bigger, right? Gets stronger. If this attraction is stronger, then these squeeze closer and closer together. Yes? All right. Atomic radius. Layering on, let's talk about ionization energy, right? Which is what? Right. The energy required to remove an electron, or we could think of it as the energy required to create a cation, right? Because we are removing electrons. As we go across a period, what happens to this? Right. IE increases, yes? For the exact same reason, right? If my radius gets smaller because there's increased attraction, that means it's harder to remove an electron, right? If we go down this way, right, IE does what? Right, it decreases because if they're further away, they're less attracted, easier to remove, right? All right, metallic character is our last one. What is that? Right, that's the tendency to lose electrons, which means the most metallic element would be francium. The least metallic element would be this, right? And so if we were to put this on here, metallic character does what? Right, it decreases across here, right? And it does what as we go down? Increases, yes? All right, make sure you look this over, make sure it all makes sense, and obviously if it doesn't, see me sooner than later. All right, thanks for listening, be good, and I'll see you soon. Bye.